This module is going to be focused on a new concept, the concept of struct, and we are going to explore some related concepts like structure, unions, enum data types, etc. So the idea is, in this module, we are going to define our own data types. But unlike what we've done so far, when we try to aggregate variables together, the variables that we put together in a bag are going to be of different types. Let me show you exactly what I mean. What we have learned to do so far in terms of putting variables together, okay, is arrays. For example, int data 5. What does that mean? That means that we have a variable data that corresponds to the address of the first element of 5 different int slots, pretty much. And that constitutes an array. An array is a sequential series of variables, pretty much in memory, that all have the same data type. So you could say data is of a new data type that is array of 5 int. Okay, we haven't said it like that because it's not array of 5 int is not really a new data type. It's a basic data type provided to us by the language, but it allowed us to group 5 integer variables together in one variable named data. And we could access each of those slots inside the array using the array notation like so. Okay? What I propose that we do now is that we group together a bunch of variables and put them inside one variable, but without the restriction that the variables have to have the same type. So I want to be able to do something such as data contains an int named value, contains a double named dValue, and contains, for example, a name, which is a string of character. Okay? So data would be our variable. Oops, here we go. Data would be our variable. I would declare a new data type. Okay? Contains that data type tells me that it contains a value, a dValue, and a name of the data type listed here. And then when I use the variable data, I would be able to do things such as data.value equals 42. Data.dValue equals 42.23. Okay, and then data.name, for example, and I would use everything that I've learned to do until now. For example, I could allocate dynamically malloc size of char times 30. And here we go. I have here a string. I have allocated enough space to contain a string of 29 characters plus the end of string marker. Okay, so that's the high-level objective for this module. We want to be able to, the same way that we had an array of multiple int slots, we want to be able to define variables that contain pretty much like we see them as sub-variables. We are going to call them fields of attribute, okay? And if you are already familiar with some of the object-oriented programming concept, like found in Java or Python, for example, you're going to think, well, this looks strangely like a class, okay? If you're not yet familiar, well, this is a heads up on what's coming up next, pretty much. This is also an idea that is very, very common in object-oriented programming language, where we group together a bunch of variables. We say, okay, now this is a new data type, and I can have variables of that data type that contain those fields, okay? One more thing here. Instead of saying just I declare data, as blah, 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 I'm going to say it in two steps. New data type, and I'm going to give it a name. For example, data type, my data contains all of that stuff. And therefore, once I am done defining this new data type, I can do things such as declare a variable data of that new data type. So my data, that's the name of the new data type, data. And then I can use the variable data like this. This part here, realistic. That's actually very, 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 very close. I'm looking for an exception here, but there's none. This is pretty much the syntax that we are going to use in the C programming language to manipulate structures. Once we have the new data type defined, there we go, we declare a variable of that data type, and then we can fill in the attributes / fields that are inside of it by using this dot notation. Okay? This part here, well, you can tell it's like mostly like a pseudocode, right? It's English. This is not the syntax. So what is the syntax to achieve this kind of stuff in C? Fortunately for us, the syntax is kind of natural. Okay, we use a new keyword, the keyword struct. The keyword struct introduces the fact that we are going to define a struct data type. Okay, we give it a name, for example, my data, spelled like that. Okay, it's not spelled the same way than the final data type that I'm going to use, because there's going to be one more step involved. And then opening curly brace, closing curly brace, semicolon, and inside those curly braces, this is where I'm going to put pretty much the definition of what I want to find inside this structure. So this new data type, struct my data, will correspond to a group of 3 fields. The first one is named value, and it's an int. The second one is named dValue, and it's a double. The third one is named name, and it's a char star, a pointer and character. Okay, so modulo like the little semicolon here, this is really close to what we wrote here. Okay, so I'm going to put this in comment. This is pretty much what we mean to declare as a new data type in English. This is how we declare it. If we stop here, what we declared is a new data type named struct my data. And the name, the full name, is actually composed of 2 words. Struct, the keyword struct, and my data, the name of the actual structure. Okay, so if I wanted to declare a variable of that data type, I would write struct my data and then the name of the variable. So same thing if I wanted to declare a parameter that is of type struct my data. If I wanted to declare anything, I would use this composite name. So that's one way to do it. First approach. Okay? And then there is another way to do it, which is, you know what, I don't want to rewrite constantly struct my data here, struct my data there, etc. I want to have a more compact type name, for example, my data, and that would be our second approach, okay, using an alias type name, okay, and the first approach is using the struct XYZ name. Okay, so XYZ represents the name of the structure that you chose. So this is called the tag of a structure. Okay, whenever you define a structure, there's going to be, well, they're not obligatory, but there can be a tag name like that, and then you can use struct followed by the tag name to declare a variable. What if you want to do things this way? Well, then you're going to use Typedef. So Typedef, again, a new keyword that we're learning. Typedef is going to allow you to say the struct data is going to correspond to a new name. So it's kind of a way to do an alias, right? A new data type name called my data. So after you define the structure my data, my underscore data, and after you do the typedef to say that this is going to be a short name pretty much for struct, oops, I forgot the my data here, for struct my data, okay, then you can use, every time you need a variable of the type structure, you can use my data instead of my underscore, struct my underscore data. Does that make sense? So the idea here is we generally follow this pattern. Okay, there are other ways to write it. The reading assignment is going to go in detail and show you, for example, how you can use one single statement, a typedef that declares a structure without giving it a tag name, and then immediately assign an alias, you know, to that structure. This is kind of like level of detail here, but right now, for this video, for this introduction, I want you to understand the basic workflow here. We define the structure with a tag name, then we define the data type name that we are going to use as a shorthand notation instead of using everywhere struct my data. So this first approach, we're not going to use it too often. We are going to generally favor, doing a proper typedef. Typedef is actually also interesting for another reason. It allows you to do things, for example, such as typedef, and you can use any data type here, okay? Any data type that has been defined. So it could be a struct that you define, but it could be also a data type like a basic data type like int. And then you could give an alias that say, when I use a data type name number of players, for example, well, that's going to refer to int. So every time you declare a variable of type number of players, var1, var2, for example, well, var1 and var2 are declared of data type int. That's what the typedef does. It's just an alias, okay? But what it does for you is that it improves the readability of your code, okay? If you put like int, and especially if you have like I chose here, I chose poor names, for my variable, var1 and var2, good luck, guessing what those variables are there for. So there's no comment explaining what the variable are there for, the names are ambiguous, and the data type is super generic. Well, again, this would be, poorly readable code. Difficult to read, even though there's no difficulty in this code. It's hard to guess what the author of the code wanted to do. So if you go and you start using data types like this, it improves a little the readability of your code, because now, even for var1 and var2, is still like a super generic name, it tells me that at least these variables are referring to something that represents a number of players. And then I can say, for example, team 1 and team 2, and with just a change of name like that, I can see clearly now that this is going to be the number of players in a team 2 for a game. This is going to be the number of players for team 1, and then I can supplement this by a little comment here that is going to further clarify this. And that would be good code, readable, easy to understand code, okay? So we have all of this syntax, the struct my data, the typedef, and etc. Okay, so we know how to declare a new structure, that we know how to typedef them to a new data type. Now, what about initializing the structure? So when you declare structure, so we're going to go away from pseudocode. We're going to remove the stuff that doesn't serve a purpose, and we're going to start compiling all of this example. Okay. So let me remove the printf hello world here, doesn't serve a purpose for our case. So I have a structure here, my data, and I'm going to declare it outside the main. Generally, you declare your structures outside every function, okay? So I have my structure, my data here. There we go. I'm going to typedef. So same thing for the typedef. You generally typedef outside of every function. So I'm moving here toward, stuff that's going to actually compile, that we can use, that we can play with, okay? And I'm going to, inside the main, use that new data type, my data, to declare a variable data. That would be how I create in memory that variable data, okay? And then this would be how I put values inside of it. So you could say that here I created a variable data, and here I initialized it, okay? So let's make sure that this code compiles. There we go. And if we run it, well, nothing is going to happen on the screen, but at least it's not crashing. So I'm correctly assigning values to this data structure. Now, if I wanted to display what I have, so if I do a printf of data, okay, what is actually the type specifier, the format specifier to display something that is a structure? There's none. You can't. You can't just display data like that as a whole, okay? Printf doesn't know how to display data, because data is a custom data type. You have put like an int, a double, and a char star inside of it, but you could have put whatever you wanted. It's not going to be able to figure out how to display it. So instead, what we do most of the time, we would have a little function called display, okay? And that function would allow us to customize how we want to display our structures. So I would have, for example, here void display, and I'm going to say that it takes as a parameter. So again, I could write struct if I can write struct my data, and I'm going to call it D, like of an imagination here. So I could define my parameter like so, or I could use the Typedef name, my data. This is a new data type, D, and that would be exactly the same, okay? And then inside of display, I could say printf, and this is how I want to display my data, pretty much. I'm going to say this is, so we talk about objects, right? We talk about an object of type my data, but this has nothing to do with how the term object is used in object-oriented programming. And I'm going to say every time I display the information about an object of type my data, I'm going to display the value, the D value, and the name. Okay, so I'm going to display the value equal %D, D value equal %LF, and name equal %S. And then go to the next slide. And now I'm going to fill in the blanks, right? So D.value, D.value, D.name. So every time I want to display one object that is my data, pretty much, I'm going to call this function. And again, it's really close to what you are going to do or you have already done in object-oriented programming, okay, where we have generally things that look really like structures that are called classes, okay, that group a bunch of variables together. And then we also insert inside that class, a bunch of functions that are called method that are meant to operate on this new data type. Well, in C, we are not yet there exactly. Things are kept separated, okay? So the structure that lists all of the variables that you want in an instance, in an object of type struct my data, right, are listed here. And then you give a name to the type here, and then you can write separately functions that are going to take, one or more of those my data parameters and work on them. Okay, so we are not yet at the level of object-oriented programming language here, but we are kind of like reinventing progressively, all of the major concepts and techniques that you are going to find in those languages. We are like going progressively toward that kind of model. So what can I do here? I can display now my data. We're going to test it. Okay, so let's go back here. Let's compile. Let's run it. And of course, the name, there's nothing, right? I allocated something, but I didn't put like a string or whatever. So I'm going to fix that. I'm going to do str copy, and I'm going to do data.name, and I'm going to say I want to copy hello inside of it. Okay. Save that. Compile. Run it, and there we go. Okay, so we declare a variable. That variable contains fields. We access the fields with the dot notation, so the name of the variable that represents the whole structure, dot the name of the field inside the structure that we want to access, and we store 42 inside of it. So inside the variable data, there are 3 values being stored right now. Under the name value, there is a 42. Under the name dValue, there is a 42.23. Under the name, there is a pointer to a string. Okay? And then I can reaccess those field values by just using the dot notation as well when I pass, for example, this as a parameter to a function. All right? So we saw how to declare, to kind of initialize a variable of type structure something, okay? How do we compare them? So this is where it gets a little dangerous, for lack of a better word. You cannot have 2 variables. So I'm going to get rid of the string just to make things a little easier and not have to do mallocs all the time. So I'm going to say, okay, I changed my mind. This is what my struct my data is about. It's just a value and a d-value, okay? And I remove the char star name. So now I'm going to modify accordingly my code here. I don't need that malloc, I don't need that string copy. And I'm going to recompile it to make sure that I show you code that actually works. And then we're going to build on it. Okay. So I have now a way to declare my data1 and initialize my data1 with those different values. Okay. And I can, of course, declare another variable like my data2, okay, and say data2, same logic, okay, value equal 999, and data2.d value, double value equal 999.9, okay, and then I can display, same way that I did it for data1, I can display, of course, the value of data2 using my little function. So let's run that real quick. Compile, run. There we go. I have my two data. So what happens now if I want to compare them? Okay. Can I do, for example, if data1 lesser than data2? No, I can't, because the C language doesn't know how to compare those things. Again, you could tell me, but I wrote here how my data is structured. Why doesn't the language know how to compare, two objects of type struct my data by comparing their value and their d-value? Yeah, but what are you doing if value is greater in one object and not the other, and d-value is the opposite? What is the outcome of your comparison? So what I'm trying to hint at here is that all of the basic comparison, like lesser equal, greater equal, equal, and different, exclamation mark equal, all of these are not defined, are operators that are not defined on any structure that you are going to create. You have to instead provide functions that are going to do this job. So we are not going to look at something that's excessively complicated, right? We're going to just write a basic function called compare, okay, that takes two different variables of type struct my data or of the Typedef type my data. So if this returns true, then I will say printf they are the same, and of course else printf they are not the same. Okay, and then a printf \n just to clear up things. So how do I write this function here? Well, what is it going to return? It's going to return a Boolean value. Okay, it's called compare. It takes a my data, we're going to call it d1 parameter, and a my data d2 parameter. And the goal is to tell me with a Boolean, just tell me true or false, are they the same? So I could have called that function actually equal, right? So are they the same? Well, how do I check if they are the same? Well, if there's going to be an if statement, right? And I'm going to check first if d1 dot value equal d2 dot value. So I'm doing the comparison of d1 and d2 field by field myself completely by hand. Okay, so I'm looking first the value field. Is it the same in both? If it is the same in both variables, I'm going to put a logical AND, and I'm going to say, so if it is the same, if that field is the same in both variables, and then that second field is also the same in both variables, then I'm going to return true. Okay? Else, return false. So of course I would not write it like this, okay? But I wanted you to understand the logic. The way that I would write it probably is just return the true value of this Boolean expression, okay? Because when the expression is true, I return true. When the expression is false, I return false. So pretty much what I'm doing here is I'm returning the value of this expression here directly to whoever called me, okay? But that's what's important to understand, is that there is no way to get that done automatically in C. Every time you come up with a new struct data type, you are going to have to rewrite things like this, functions to display a variable of that data type, function to compare to variable of that data type. And here I just did the comparison to make sure they are equal to one another, but I could also have a more complex comparison. For example, I could say that my D1 is greater than D2 if both actually value and d-value in D1 are greater than value and d-value in D2. If both are lesser, then D1 is lesser than D2. If one is greater, one is lesser than its counterpart in the other variable, then maybe I'm going to say I cannot compare them. Okay, so you are free to completely define the concept of order on your new data type, and this is really powerful when you think about it. Okay. And this is going to be something that you're going to use much more in object-oriented programming, where most of the activity is spent actually defining new data type called class, right? And the class, I kind of think of them as struct on steroids, okay? All right. So we have compared our structures. We have accessed the fields of structure. What's left for us to do? Well, let's try to throw in a little bit of pointers into this, because, you know, pointers make everything more fun. So let's say that I have, first, how would I declare a pointer on a variable of type struct myData or myData star, and I'm going to call it PTR, okay? I'm going to initialize it to null, because I should initialize every pointer I declare to null if I don't know better. And then PTR equal, let's say that I want PTR to refer to data1. PTR equal address of data1. So nothing new. What you can do with an int variable and a pointer on int variable, okay, make that pointer on int variable points to that int variable and then use it, you know, like this, star PTR to dereference. You can do with structure. There's just a little bit more syntax. How do I act on data1? How do I modify data1 using the pointer PTR? Well, I'm going to dereference the pointer PTR. Okay, so PTR contains the address where the structure represented by data1 is. I dereference PTR. Now I'm looking at that structure. And then dot notation, value equal -1. Okay, so if I display again here data1, we're going to see that it has changed its value. So I have not compiled it a little bit, so let's take this opportunity. So we have two variables, data1, data2. They are not the same. That's what my comparison algorithm tells me. But you are going to notice here that I first display data1, then I display data2, then I modify data1 by putting a -1 instead of 42 in the first field, the field name value. I display it again. It has been properly modified. So the notation for pointers is very similar to what we've learned, okay, except that we have to add to it what we just discovered about the dot notation to access the fields inside of a structure. So this gives me a structure. This here gives me this here, data2, gives me a structure. This gives me a structure. And every time I have a structure, I can follow it by a dot and the name of a subfield, okay, of a field, and that allows me to assign a value to the field inside that structure. Okay, simple enough. Well, there is one more complication, okay? PTR is a pointer. So I can dereference a pointer. So you have your pointer, you have your data, your struct, you know, somewhere else in memory. So you dereference the pointer to go to the struct and then use a dot notation on the struct like you did with any other struct variable. Well, there is another notation available. When you know that you have a pointer to a struct, okay, you can, without dereferencing the pointer first and then using the dot notation, you can do both steps in one action. You use a new operator called the arrow operator. It's just a minus immediately followed by a greater than sign, no space in between whatsoever, okay? if you write ptr arrow and the name of a field, it's going to be exactly the same thing than writing star ptr dot. It's just that sometimes it's more convenient to explicitly say I dereference the pointer, and now that I am looking at a struct, I use a dot notation. Sometimes it's more readable to say, listen, I have a pointer on a struct, I want to do pointer arrow and immediately tag the field inside that struct. So if I run this, we're going to modify twice value. Actually, I should modify the value. There we go. Just to show you that we can modify both, gcc a.out, and we have modified indeed both value and then the value using the different pointer notation. Okay. All right. With this, we have kind of the basics of manipulating structure data types, how to create them, how to declare them as parameter of function, how to assign values to them, how to use them alongside pointers, things like that. The last thing I'm going to add is that when you pass when you pass an argument that is actually a struct variable, right? It's passed by value to your function. And once we say that, then you have all the little pieces of syntax and rules to follow that allow you to use struct data types in your program. So we are going to wrap it up here for this video. And next video, we are going to expand a little bit what we have learned on struct to other types of new data types that we are going to create in the C language called union. As usual, thanks for your attention, and I'll see you in the next video.